And now we come towards energy. As I have made you clear earlier, that energy is the capacity of doing work, or it is energy means that is capacity of doing work, or it is, we can say that if force applied will be more, or energy basically depends upon the force into displacement. So if more force will be applied, energy will be more. Now, in the concept of energy, as it is clear from the definition, which I have explained earlier, the energy of body is defined as the capacity of doing work. There are various forms of energy. So we can have various forms of energy, and these energies are mechanical energy, the chemical energy, the electrical energy, the magnetic energy, nuclear energy, the sound energy, and light energy. Well, mechanical, all energies are expressible in terms of joule. However, we can use some other units, like mechanical energy will be in joules, or it is, that is, joule means that is the work done. So electrical energy can be in joules as well as in kilowatt hours. The nuclear energy can be in joules but also in electron volts or kilo electron volts. You can further remember that 1 electron volt is equivalent to 1.6 10 to the power minus 19 joules. The light energy is normally exhibited, light energy in terms of lumen, or light energy is basically joules, but otherwise we can also use another unit that is called intensity of light, or the lumen. And similarly, chemical energy. So chemical energy is expressed in joules. Magnetic energy is in joules, but at the same time, we can express this energy in Webers also. Sound energy, that is expressed in joule, but also we can explain in terms of decibel. So we can remember that our eardrum is very sensitive and it responds to 10 vibrations in 1 second. That is, 10 syllables of sound will be responded in 1 second by the normal human eardrum. Now, energy of system always remains constant. It can neither be created nor it can be destroyed. However, it may be converted from one form to another. This is called law of conservation of energy. So if we take that a particle is at a certain height and it has got only potential energy and kinetic energy will be zero, then total energy at that height will be mgh plus 0, and that will be equal to mgh. Now, if suppose that particle starts coming down towards the ground, we will find its potential energy goes on decreasing and kinetic energy goes on increasing. But if we take the sum total, we will find that it will remain mgh, where mg is the weight and h is the height. And now electrical energy, that can be converted to mechanical energy with the help of an electric motor. Now, another thing is mechanical energy that can be converted to electrical energy with the help of generator. Then we come towards the light energy. This can be converted into electrical energy by using a photocell. That is, in a photocell, there is a cathode plate and there is one anode plate. Ultraviolet light is made to fall on the cathode plate and electrons are ejected out from the cathode plate. So, those electrons will constitute current or will energy. So, this is how the light energy is converted with the help of photocell into electrical energy. Then comes electrical energy, and that is converted to heat energy. One of the very good examples is a heater. There are many other examples like filament of the bulb. When we pass electricity in the filament of the bulb, it glows, and after some time it gets heated up. Now we come towards electrical energy converted to sound energy. So the procedure will be that electrical energy with the help of the radio waves is transformed into sound energy. Sound energy is called the audible sound, and audible sound is having less velocity, 332 meters per second. So this sound energy is superimposed on the radio waves, that is called modulation, and then it is communicated to a long distance. Now we come towards the nuclear energy. So nuclear energy is converted to electrical energy in the power plants, and one of the power plant is called a nuclear reactor. Nuclear reactor where we use 92 uranium 238, that is natural uranium, and it is transformed into uranium 235, and then that uranium 235 is bombarded with slow neutrons. Then we find that some energy is released, which is nearly 200 million electron volts per atom. That 200 million electron volts per atom is converted to electrical energy. Now we come towards the chemical energy. With the help of cell, it is converted to electrical energy. Then we come to electrical energy, and with the help of secondary cell, that is the lead accumulator, is converted to chemical energy. Now we come towards the heat energy, and that is converted to light by using an incandescence lamp. So incandescence lamp is using the heat energy, and that heat compels that lamp to glow, so light energy is generated. Now energy is a scalar quantity. Its unit is the same as that of work or torque. Well, you can remember that torque is the product of force and perpendicular distance. So its unit is same as that of work or torque. Torque is sometimes known as the moment of couple, and that is calculated by the product of force and perpendicular distance. Now in MCAS unit, the unit for work or torque, it is joule, watt second, and in CDS system, it is hertz. Now we come towards an important note, but this I have already explained, that electron volt is a nuclear energy and its mechanical equivalent is 1.6 10 to the power minus 19 joule. Similarly, kilowatt hour is equivalent to 36 into 10 to the power 5 joules, or it can be written as 3.6 into 10 to the power 6 joules, which is equivalent to 3.6 million joules. When we use the term 1 kilowatt hour, that tends to that 1 unit of electricity. So if we say that in a household system, we have spent 100 units of electricity, that means that we have consumed 100 kilowatt hours. And 1 kilowatt hour is 36 into 10 to the power 5 joules. So we multiply this number by 100, and that will come the total work done to generate number of kilowatt hours. 1 joule is equivalent to 10 to the power 7 ergs, that is the CDS unit. Now dimensions of energy are the same as that of work. So if we wanted to find the dimension, energy is the capacity of doing work, that is E is equal to W, and W is equal to F into S. For F, we can put the dimension MLT minus 2 multiplied by L. S will stand for L. And then we brief the dimension, that is M1 L2 T minus 2. Now, according to the Einstein mass energy equivalence, mass and energy are interconvertible, that is, they can be changed into each other. One other important thing suggested by Einstein was the special theory of relativity, which is m naught is equal to, or m dash is equal to m naught over 1 minus v square over c square under root, where v stands for velocity with which the elementary particle is moving. So there is an equation, m is equal to m naught over 1 minus v square over c square, and this is called the consequences of the special theory of relativity, and this gives the moving mass of the particle. However, this theory was first of all explained in 1905, and it has been further modified in 1920 by using the general theory of relativity, that is E is equal to mc square. Einstein was awarded the Nobel Prize on photoelectric emission. Energy equivalent of mass, that is given by Einstein equation, that is E is equal to mc square. M is the mass of the particle, c is the velocity of light, and E is the equivalent energy corresponding to mass. So it is not necessary that momentum can be exerted only if the body has mass. Momentum can also be exerted if mass is transformed into energy, and that energy moves in the form of waves. That is, wave can exert momentum. The important example is the light radiations and ultraviolet radiations. They are not particle, but they are exhibiting the dual character, so they can exhibit photoelectric emission. Now we come towards That is, in mechanics, we are concerned with the mechanical energy only, and this mechanical energy will be of two types. So one of them is called the kinetic energy and other is called the potential energy. Kinetic energy is the energy due to motion of the body, whereas potential energy is the energy due to position or condition of the body. If we integrate momentum, our result will be half mv square. That is kinetic energy. So kinetic energy is calculated by function half mv square and potential energy is calculated by function mgh. Now we come to the main context, that is one of the energy is called kinetic and other is called potential energy.